Hai, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. My name is Muhammad Fatimi Al-Amin bin Muhammad Fadzulli. The student ID given to me is 2020834046. For today, I would like to answer the question that has been given to me by Sir Idris bin Sa'ad, which has been located at Note Chapter 3, First Law of Thermodynamics, Part 3, Energy Balance for a Closed System. Okay, without wasting any time, I would like to jump into the question. I've been given question 3.2, question number 5. It sounds like this. A piston cylinder device contains steam initially at 1 Pascal for 150 Celsius and 2.5 meter cube. Steam is allowed to cool at constant pressure until it first starts condensing. Show the process on TV diagram with respect to saturation lines and determine A. The mass of the steam, which is the answer is 7.565 kilogram, and B. The final temperature, which is 179.9 Celsius, and C is the amount of heat transfer, which is the answer is 4,495 kilojoule. Okay, let me show you the answer real quick. Okay, for the first one, we have to determine the mass of steam. To determine the mass of steam, which is M, we will use the given volume, which is a V1 equal to 2.5 meter cubic, and the initial specific volume, which is that is the symbol. The initial specific volume we can determine using the given initial pressure, which is P1 equal to 1 M Pascal, and initial temperature, which is T1 equal to 450 Celsius, and by using the appropriate software. So the initial specific volume equal to 0.33 meter cubic over kilogram. Then we can calculate the mass of water, which is M equal to V1 over initial specific volume. So we get the answer 7.58 kilogram. Okay, we move to the next question, which is we need to find the final temperature. The process is isobaric, meaning the final pressure is also P2 equal to 1 M Pascal, and from the problem we know that the final phase of the water is saturated vapor. This means that the final temperature T2 is the saturation temperature at the given pressure, which means you can determine the final pressure, which is 179.88 Celsius. Okay, we move to the amount of heat transfer. In the final part of the solution, we need to determine the heat transfer, which is Q from the energy balance equation. We will have two terms: the boundary work and the change in internal energy, which is delta U. The kinetic and potential energy changes are zero. We start with the calculation for the work, which is W. For that, we will use the isobaric work equation, and for it, we will need the initial V1 and the final V2 volume and the pressure. The final volume, which is V2, we can calculate by using the given calculated mass, which is M, mass of water, and the final specific volume. After that, the final specific volume we can find in the table for saturated vapor at 1 M Pascal. So for final specific volume, we have 0.19436 meter cubic over gram, and so we will use the formula V2 equal to M dot initial M dot final specific volume. So we calculate that, we put the mass of water and the final specific volume, and we calculate, and we get the answer for final volume, which is 1.473 meter cubic. After that, we have to calculate the work, which is we use the formula work equal to P times V2 minus V1, which is we calculate that and we get the work is negative 1027 kilojoule. For the internal energy change, delta U, we will need the mass of water and the initial and final specific internal energy. We can find both by using the appropriate software, which is the value of initial specific internal energy is 3040 kilojoule per kilogram, and the final specific internal energy is 2582.8 kilojoule per kilogram. So the internal energy change is then we use the formula delta U equal to m over the initial and the final specific internal energy. So we calculate that. We use the mass of water, which is 7.58 kilogram, and we put the value of initial and final specific internal energy. So we get the internal energy change, which is negative 3466 kilojoule. And for that, we want to calculate the heat transfer, which is Q. So the formula that we want to use for calculate the heat transfer, which is Q equal to work plus delta U, which is internal energy change. So we put the value, which is the work, is negative 1000 over 27 kilojoule minus by the internal energy change, which is 3466 kilojoule, and so we got the heat transfer is negative 4493 kilojoule. So that is the answer for the amount of heat transfer, which is Q. So after that, I want to move to the TV diagram. From the TV diagram, we can see the process. Isobaric processes are curved in the TV diagrams, and we can clearly see that the initial point is in the superheated area and the final point is at the saturated line. So as you can see at the TV diagram right here. I think that's all the solution from me. Thank you very much for your time.